beats. Holla at me.
Hey guys, continuing on with 2.5. Now we're going to talk about horizontal stretches and horizontal... Oh, holy shit, I spelled that wrong. Let me just fix that up. Outstanding. Let's continue with this. So in horizontal stretches and compressions, we're looking at the C value in the whole equation. So if we take that down over here, that's how we determine whether it's a horizontal stretch or compression and by what factor. So it's kind of different than the A value for vertical, in that for the C value for horizontal stretches and compressions, if C is greater than 1, then it's a horizontal compression, and if C is less than 1 but greater than 0, it's a horizontal stretch. That's true because we take that C value and reciprocate it to find out what we're multiplying the X values by. So let's look at the graph over here, y equals fx, and we have the table of y is 0 to 5 and x 0 to 5. If we take that and apply a horizontal compression by a factor of 1 over 2, it's written as 1, 2x. Close that. So that C value, we take that and we reciprocate it to find out what we're multiplying the X values by. So reciprocal of 2 is 1 over 2. So that graph now becomes, or the table, let's fix that first. So the table becomes 0 still stays at 0, 1 becomes 0.5, 2 becomes 1, 3 becomes 1.5, 4 becomes 2, and 5 becomes 2.5. So we're going to draw that out. You can tell that it's a lot shorter on the X value. So now let's look at a parabola. So we're going to take the y equals x squared. Here's the normal table of values with the x value being -3, -2, -1, 0, 1, 2, 3, and the y values being 9, 4, 1, 0, 1, 4, 9. And let's apply a C value of 1 over 2. So y equals 1 bracket 1 over 2 x squared. So looking at that, we have to take this 1 over 2 value and reciprocate it. So that becomes 2. So that means we're multiplying the x values by 2. So making another table of values, the y values stay at 9, 4, 1, 0, 1, 4, 9, but the x values become -6, -4, -2, 0, 2, 4, and 6. So drawing that out here, we start at -6, so 1, 2, 3, 4, 5, 6, and we go all the way up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Looking at -4, so it's -4, and we go up to +4. -2 is at 1, and 0 is at 0, 1 is at 2, 4 is at 4, and 6 is at 9. Great. So you can see it's a little wider than a regular parabola. That's because we applied a horizontal stretch to that. So looking at this over here, let's create it with let's create an equation with a vertical stretch. So let's say we have 1 over 2 x squared equals y. That means that we have the same table of values for the regular parabola. So yx, 9, 4, 1, 0, 1, 4, 9, -3, -2, -1, 0, 1, 2, 3. However, we apply shifts or changes to the x and y values. So I'm going to I'm going to erase this, all of this goodness, and draw you guys another table of values. So let's have y and x. So now since we're applying that vertical stretch of 2, the 9 becomes 18, the 4 becomes 8, the 1 becomes 2, 0 stays at 0, 1 becomes 2, 8, and 18. Since we applied a C value of 1 over 2, that means it's a horizontal stretch by a factor of 2. So that becomes -6, -4, -2, 0, 2, 4, and 6. a giant changed parabola. Thank you for listening.
Hey guys, previously you have learned about the different transformations, including reflections, stretches, and compressions. 2.6 consists of all the different transformations combined in one equation. So let's go through an example. Given the equation y is equal to the square root of x, graph the equation y is equal to negative 3 square root of negative 2x minus 2 on the same graph. Personally, I like graphing using the table of values, so to save time, I already made them. So to start off, we have to see what is affecting the x value. So as we can see, there is a horizontal stretch by a factor of 2. And previously, we have learned that the c value of the equation is reciprocated. So in this case, the negative 2 becomes negative 1/2. And that's how I got negative 1/2, negative 1 over 2 on the left side of the table. Next, we have to see what affects the y value. So as we know, the a value and the k value are what affect the y values. So we know that on the right side of the table, it would be negative 3y minus 2. Now we just plug in the original values of the x and y values to get our new transformed graph. So because I already did the table, we'll just plug it in. So 0, negative 2, negative 0.55, negative 2 and negative 8, negative 4.5 and negative 11, and negative 8 and negative 14. And don't forget to put the arrow. So now that we've done that, let's learn how to create our own equation given information about the graph. So, for example, the graph of y is equal to x squared is expanded vertically by a factor of 3 and translated 4 units to the left and 6 units downwards. Write the new equation. So as you can see, I underlined 4 different parts that change the equation. So let's take this step by step. So first we learn that the equation, that the parabola is y is equal to x squared. The next thing we learn is that it is expanded vertically by a factor of 3. So we know that it has an a value of 3. Next, we learn that the parabola is translated 4 units to the left. So this equation would be 3 bracket x minus plus plus 4 squared. Because as we learned before, anything in the bracket is opposite. So to the left would be positive and to the right would be negative. And lastly, 6 units downwards. So that would just mean that the k value would be negative. And there you go.
Hey guys, this is section 2.7, and we're going to be talking about inverse functions. So inverse functions are kind of weird because it's usually parabolas open up and downwards. This time the parabola opens sideways sometimes, but I'll talk about more about that right now. So I'll explain it. So an inverse function is when a graph is reflected on the line y equals x. It's this line over here. So let's say we have the regular parabola y equals x squared. The way to solve for it is if you have the points, you can reflect it on that line. So over here there's 1 is 1, 2 is 4, blah blah blah. So you have your parabola. But if you're trying to do the inverse function, you have to reflect it on this line. Now, you can't have numbers below the x, so it ends up only being half the parabola over here. So let's actually look at how we solve that. The way to derive a inverse function is when you have your regular function, you switch the x and y values and solve for y. So let's say we have y equals x squared. That becomes x equals y squared. So to solve for the inverse function, you square root both sides, and that becomes root x equals y. So y equals root x, and that's how you get over here. Now you can't have below the x-axis because you can't have a root of a negative number. So that's why it's only over here. But if you look at that, that is perfectly reflected on the line y equals x. So let's look at an actual formula over here. Let's say we have y equals 4x squared minus 1. The way to solve for the inverse function is to take this parabola and change the x and y values. So that becomes x equals 4y squared minus 1. Let me just erase this. So now solving for that, that becomes x plus 1 equals 4y squared. X plus 1 over 4 equals y squared. Root x plus 1 over 4 equals y. So y equals root x plus 1 over 4. I actually have no idea how to draw that, so I'm going to come up with a simpler function. Let's say we have y equals 2x squared. Switch up the x and y values, and that becomes x over 2 equals y squared. So y equals root x over 2. So let's draw a table of functions over here, or table of values over here. So we have x at -3, -2, -1, 0, 1, 2, 3. So plugging in the formula over here, we have root x over 2. So -3 over 2 becomes -3 over 2, and you can't root that. So that applies to all negative numbers. So these three are not applicable. Start with x. 0. 0 over 2 is 0, and root 0 is 0. 1 over 2 is 1 over 2, and root 1 over 2 is root 1 over 2. I don't know the exact value for that. 2 over 2 is 1, and root 1 is 1. And 3 over 2 is 3 over 2, and that becomes root 3 over 2. So let's draw that up here. So we have to start at 0 and 0. Then we have 2 and 1. And then let's say we continue this to 4. That'll be 4 over 2 equals 2, and root 2 over here to 5. 5 over 2 becomes root 5 over 2, and 6 becomes 6 over 2 equals 3, and that becomes root 3. So we're drawing down the values over here, or the graph I mean. We have root 2 somewhere around here, root 3 over 2 somewhere around here, and root 3 over 2 somewhere around here. So we continue that, we get an inverse function that goes like that and continues on. So we'll have a line just around here, we'll have another line just around here, and just complete that on the x-axis, and then so the parabola will start and kind of curve, and we'll complete the curve, and there'll be a little circle over here, and just the finishing touches. We have 3 lines on each side.